This is one of the most powerful gaming laptops in the world. And yes, of course it can game, but what you're watching right now is not a game. That's a video generated by an AI model running locally on this laptop, in case you couldn't tell. Oh, and there are two of them. Identical twins. Well, almost. This one's got an nvidia RTX 5080 in it with 16 gigs of VRAM, and this one's got a 5090 in it with 24 gigs of VRAM. The difference between these machines isn't speed. They got the same processor, same RAM. It's VRAM. And that turns out to be the whole story of local AI. But before any of that, these are the MSI Raider 16 Max HX. And of course, they're gaming laptops first. So I had to check that out first. So in case you're not familiar, these are brand new and they've got Intel's Core Ultra 9, 24 cores of it, 32 gigs of RAM on each one of these. And the whole reason we're here today is that sweet nvidia RTX 5090, which is gonna show us what it's capable of in this laptop format. And of course, it's 5080 twin as well. Like I said before, everything is exactly the same. Even this gorgeous OLED screen, which if you're a developer and you're staring at a screen all day, yeah, it's gonna be nice for you. And developers play games on their time off sometimes, or sometimes during work when they shouldn't be. And check this out. There's actually a quick access panel. You just pop that open and right there you have access to your RAM, bam, and the SSD. Probably shouldn't have done that with the laptop on. I was just so excited. I need to turn this off ASAP. Bad Alex. So yeah, that 32 gigs that it ships with, you don't have to stick with that. You can get something like this and yeah, increase that memory. And of course, because this thing is built for gaming, we've got some serious cooling headroom here. These fans on the bottom are crazy. This thing is designed to run flat out for hours without breaking a sweat. Of course, keep the 400 watt power brick handy because you're gonna need that. Also, RGB everywhere, but I prefer to turn that off. That's just not my thing. Please turn on. Please turn on. Oh, yes. Signs of life. Just before we kick off the AI tests here, which is what this video is about, just want to mention that this is really cleverly laid out. We got USB-A ports here on the right, along with a headphone jack. I've got two Thunderbolt ports on the left, along with an SD card reader, exactly where I would need them. And the stuff I don't normally need is on the back. HDMI, you plug that in and you're done. Ethernet port is back there. The power plug is back there. They're not taking up side real estate. Kind of like that. I daily drive a MacBook Pro and I wish maybe it would adopt some of that, but I'm sure we'll have some comments about that in the comment section. All right, let's climb this ladder. Now, of course, you have the ability to easily run llama on this, which is a tool that's pretty familiar to all of you by now. And right now I'm running llama pull Qwen 3.54b. By default, llama is gonna grab the 4-bit quantization, which means it's only gonna be, what is that, 3.4 gigs in size? Pretty small model. And for those of you that are not familiar, quantization, when you quantize a model, you squeeze it. So you're basically taking a 16-bit model weights and you're compressing it down to 4 bits in this case. And we have 16 gigabytes of VRAM on this machine. We have 24 on this one. So you're gonna need to be able to fit your models within that space. As I'll show you, it'll run larger models, but speed is going to suffer at that point. We'll get into that momentarily. Llama run, verbose, and go. Now this is a small model, so you're most likely gonna be just chatting with it. I know you're all gonna love this, but I'm just gonna say hi to it. And boom. That is incredibly fast. And it's fast for a few reasons. Let's be clear about that. These are NVIDIA RTX GPUs in there, and they're running CUDA, which is a software stack by NVIDIA that allows you to run AI on machines like this, as well as huge data centers with server racks. And the CUDA stack excels at running AI. 151 tokens per second here for the token generation on the 5080, 146 on the 5090. Interesting. Now, if you're chatting here, you read about 5 words per second. So this is about like 30 times faster than you can read. Not a problem. Now, besides llama, another really popular tool is LM Studio, which I've shown on the channel many times before. This model, Gemma 412B, also a 4-bit quantization, is 7 gigabytes on disk. We're going a little bit larger now. We're still under that 16 gigabyte threshold. We don't want to cross that. Now, that includes the model size plus the context. The context is your entire conversation. and anything that's included in it. For example, if you're using this as a coding assistant, you're going to be sending it along with your prompt. You're going to be sending it the code base or some of the code base, whatever your agent decides is appropriate. But for now, we're just chatting. And for the kind of chat that I'm having with it, I don't need a huge context. I'm just looking to see how fast it goes. So we're using 16 gigabytes out of 32 available on the system. And initially we load into the system RAM, and then we go into the GPU right here. So here's the 5090, and there's the dedicated GPU memory. And you can see we've loaded about 10 out of the 24 available. Similar story on the 5080. Here's the GPU, and we are loading about 9.1 out of the 16 that's available there. And go. This is a thinking model. So initially it's gonna do a little thinking, and then it's gonna spit out the text for me. Funny that both of these stories are about some kind of shop, but they're clearly different stories here. So we've got 61 tokens per second here on the 5080 and 64 tokens per second on the 5090. Not a huge difference, but it's still pretty ridiculous speed, because if you're chatting, that's more than you need. Now, by the way, if you're familiar with Llama and LM Studio, they run on an engine called llama.cpp, which is a command line tool that you can run and use it as a server. You can chat with it also. So I ran a bunch of models on pure llama.cpp, so there's no performance implications. And I got some scores here. I'm looking over here because that's where I have the scores. Qwen 3.54B, Gemma 412B, we already seen these. Slightly different numbers, but within the margin of error. And you can see the difference between RTX 5080 and 5090. Not huge. GPT OSS 20B is also one of those popular models, even though it's already getting pretty long in the tooth, but it's fast. It's a mixture of experts model. The other two on this chart are dense models, which means all the parameters run. So the 12 billion parameter model, 12 billion parameters are active. 4 billion parameter model, 4 billion is active. But in 20B, I think 3 or 4 are active. I'm sure somebody in the comments will correct me there, but not all the parameters are active. And that's why it's so much faster. Now that was token generation speed from scratch. All those fit in 16 gigabytes, easy. So extra VRAM isn't buying us speed. It's just that the 5090 has more CUDA cores than on the 5080. So it has more cores on the chip on the GPU. The numbers are not that far off, and that's because I gave it really short prompts. So there's not much computation happening there on the GPU. Now what happens after you've had a little bit of a conversation and now you have a lot of context built up? Maybe not a lot, but I also ran this with an 8K context. That's 8,000 tokens of history already in the chat that gets repeated back into the GPU, sent back to the GPU as your context, so it has to process more. Well, it slows down just a little bit, but basically we have pretty much the same pattern. There's one more very important number to consider, and that's the prompt processing. That happens actually before the generation, so maybe I should have done that first. That's when you send the input and it gets processed by the GPU. That's the computation. And this is much, much faster. We're talking about 5,104 tokens per second for Qwen 4B and up to 6,983 on the RTX 5090 for GPT OSS 20B. Now here's the thing you actually need to understand about local AI, and it's one of the reasons I have these two laptops here. The difference in VRAM. VRAM decides which models you can run at all. You can think of it like doors. 16 gigs opens every door we just walked through so far. 24 gigs will open up a few more doors at the top. So everyday chat, brainstorming, the stuff most people will pay 20 bucks a month for. You know what I'm talking about? Yeah, that's covered. And local never leaves the machine. But chat is easy. Can you actually use this for work? I jumped right into an oldie model, but a goodie model, because this model is very good for coding, or at least it used to be, but it works very well with code editors. Like here I've got VS Code running and I'm using the Continue plugin, and it's Qwen 3 Coder 30B running locally in llama.cpp. Let's actually pop open the task manager so you can see what's going on. And there's that dedicated GPU. The memory is 23.3 gigabytes out of 24 with 131,000 context windows. So yeah, we're at that limit. I wonder what's gonna happen on the 16 gig machine, but first let's try it here. You can see that GPU is not active right now. I'm gonna select that model and just say hi to it. I know, you all hate that, but it's a proof of concept, okay? And you can see that little spike on the GPU right there. That's where it answered me. Okay, fine, I'll give it a longer prompt. I'll give this architecture prompt, which I sometimes let's use design a scalable web application architecture for an e-commerce platform and so on. You can read it, pause the video if you want to. This is a good prompt because not only does this have to process the prompt, it's not that long, okay, but what this does is generate a very, very long response for me. And that's pretty much how fast it's going on this machine. It's a big model, so it's not gonna go super fast. But there's that GPU being very, very busy. 99 to 100% utilization. Now, Continuous Agent also has tool use capabilities here. So it's going to create new documents and it's going to put the architecture.md file and everything related to it into that document instead of spitting it out here. Hey, that's whatever works. I do hear the fans spinning up on this thing, so it's working hard. Let's see what happens over here. I have the exact same setup here. Select Quencoder 30B and let's do a little high here. Oh, this one's taking a little bit longer to answer. Now this model is pretty popular, but it's 61 gigabytes, full-size model. And we're running a 4-bit quantization here. Here's an example of one. The 4-bit quant is 18.6 gigabytes in this particular case, but usually it's going to be around there. So that's just outside of what this GPU has available. We finally got an answer here, but that took a while. That's because it started spilling over to system memory and the CPU in order to run this model. Now 30B is a bit of an older model. There's some newer models that are around now that are taking over for the development space, especially in this smaller model range, smaller to medium-sized model range. And we're going up right against that limit right here on the 5090. The 5080 can do it, but it's having a little bit of a time keeping up. So we've got Qwen 3.5 27B, Coder 30B, the one we just ran here in the editor, and Qwen 3.6 35B. By the way, the 27B, that's a dense model. All 27 billion parameters. That's the largest, densest model that I've run. We're getting 9 tokens per second on the 5080. The other models are mixture of experts models. And let's take a look at the 5090. You can see quite a difference there. More than double, even more than triple in certain cases. That 27 billion parameter model definitely has some CPU and system memory spillover, so it slows us down quite a bit. At that point, you're looking at the 5090 machine. 9 tokens a second is pretty unusable at that point. Although Coder 30B still looking pretty decent on both of these machines, although it's going to be 2 times faster on the 5090 machine. And finally, the mixture of experts 35 billion parameter model, Qwen 3.6. Yeah, same story there. Same goes for the 8K context. We're down to 8 tokens per second here, which is actually not a terrible drop there. All these bigger models have slower prompt processing than GPT-OSS or the small model because there's just so much to chug through. There's always this balancing act that you have to work with. The larger models will obviously be heavier and they'll take up more memory, and you want to use the larger models because they're smarter with with your code editors, but you have to balance it out. That's why I still do Coder 30B because it looks pretty nice here, doesn't it? Here I've got Flux, a 12 billion parameter image model. It's running inside Comfy UI, everybody's favorite image and video generation tool. It's powerful, okay? And go. This one's pretty quick. Video generation is another story. Oh, this is all local. Did I mention that? There's no you only have 2 generations remaining messages or errors. No sweat. You can do this as many times as you want. Done. It was about 45 seconds or so to make this image. Now, images are pretty easy thing. What about video generation? Here's WAN 2.2, and I took that same image that got generated and plugged it in here. So we're doing image to video. And you've kind of already seen a preview for this because you saw the beginning of the video, maybe? Well, that was one example. Here's another one. It's a game sim racing, and something happened to that speedometer after the first frame. Don't ask me what, but that's how things are these days. It's not perfect. This took 3.5 minutes, 3 seconds, 81 frames. That's speedometer though. What happened to kilometers per hour? Is it really that hard to spell out kilometers per hour? Come on, love it. And by the way, the smaller twin can render all the exact same stuff, but 4 minutes instead of 3.5. That's the whole difference. Not huge, So how are gaming laptops able to do all this? Well, it's the NVIDIA GPUs inside with their tensor cores, dedicated GDDR7 VRAM, the Intel Core Ultra 9 inside. That's used when you have your agents working away. The agents do most of their work on the CPU, handing things off to the GPU to the models. Who would have thought that gaming hardware like this would have been so perfectly suited for AI in today's world? So not only are you getting a good gaming machine if you get one of these, but you're also getting a top-of-the-line NVIDIA CUDA stack GPU inside of one of these. And if you have a requirement for running local video and image generation or running local models, your code doesn't leave your system, it doesn't get any better than this because there is no RTX Pro 6000 laptop. Well, not yet. And I don't think there will be. So this is kind of like the top of the line. And of course, you're on the CUDA stack. Best in class. Anyway, it's kind of a pleasure to run laptops that are really solidly built and present absolutely zero hiccups while being used. I like that. I'm used to that with my MacBook Pro. And I really appreciate being able to run the NVIDIA hardware in machines like this. If you enjoyed this video, you're probably gonna like this one next. Thanks for watching, and I'll see you next time.